Hello, everyone. Welcome to Next Big Future. I'm Brian Wong. I'm a futurist, Tesla and SpaceX stock owner, investor, and also been a blogger for almost 20 years, where I've done research on over 30,000 articles about science and technology in the future. So I'm going to talk about, or today, what I think will be a huge development for Tesla and SpaceX and humanity. And that is the fully and rapidly replicable factory. Fully and rapidly replicable factory. So these things, fully and rapidly replicable factories, will be the highest impact economic development ever made. I think that, it's, as a futurist, go back through history, I'm talking about, bigger than the wheel, bigger than fire. It's like it will be the hugest impact on speeding up economic development, technological development that we ever make. That's even more impactful than creating immortality. Immortality would be huge as a benefit for humanity and for the people of it, and improving health. But the economic impact actually would be less than having replicating factories, self-replicating factories, where the entire supply chain is rolled in. So I can talk about this. So that Elon has hinted at this development. He hasn't said it explicitly, as he's talked many times about fully and rapidly reusable rockets as the holy grail for space. That's what he's trying to do with the Super Heavy Starship, where both pieces are used. You don't throw anything away. And that's the difference between the Hindenburg and passenger planes. Hindenburg flies once and crashes and burns, just like rockets fly before SpaceX fly and crash and burn, one use. And planes and cars are transportation that you use over and over again. You don't throw anything away. And he said that's the holy grail for rocketry. Okay, because that can have a huge impact. And I'll describe how much impact. People don't fully understand how much impact that is, and I'll quantify that for people. But Elon is talking about manufacturing is Tesla's long-term advantage, that they will manufacture better. And he's talked about the machines that make the machines are the important thing. So machines making other machines and development of that, like the machine that makes the factory robot, the machine that makes the gigapresses, and improving those things, each of the machines that make the machines. And he's talked about the factory is the product, that the gigafactories themselves constantly improve, speed up. Before that, the pinnacle of factories was the Toyota factories, where they mastered quality production and the Toyota process being the thing. But that was the thing for decades, and it didn't change that much. They did it once, they got to lean manufacturing, and then not much improvement. Things became static. In order to maintain quality, they try to maintain things static, while Tesla constantly improves and changes. They make changes 20 times a week, 1,000 times a year on the factory line, and the factory themselves are changing. The product can get faster and faster. An example of this was that the Tesla Shanghai factory at the beginning of last year was pushing out a car at the end of the line every 2 minutes. Oh, that's amazing. They're putting out a car every 2 minutes. By the end of the year, 12 months later, it was practically every 30 seconds. So it's 8 hours to get through start to finish. Or maybe start at 10 hours and get shut down at 8. But the coming out, the end, was speeding up by 4 times. And Elon has talked about speeding up the factory line, that the production line is slower than someone walking. If you speed it up to the pace of someone walking, it's 5 times faster. And it's talking about making 10 to 100 times improvement. But factory is a product. So the machines that make the factory that make the factory is a step, just the next step from those statements. Raw materials in and products out of the gigafactory. That is something that in the last quarterly and annual report that Tesla gave, Elon and his team, the CTO, and CFO talked about that for the new gigafactories in Austin and Berlin, raw materials go in toward the top of the factory for the battery cells. And then the battery cells get made, they get dropped down the next floor where the cells get put into packs. The packs get put into the right point in the assembly line where they get added into the cars. But raw materials come in and then the products come out. So, you know, the lithium, the nickel, those things are coming in raw form and then being converted into completed vehicles. So, but that's the thing of integrating the supply chain, what's going into making the components into the factory itself from raw materials, versus other manufacturers like Ford or Volkswagen, you know, they take parts made by other companies. So, and it could be like a series of companies that, you know, steps removed from getting the raw materials until they make a part. So some company could be getting the parts for a component of the drivetrain. Another company's taking those parts and making the you know, part of the drivetrain and transmission, and then those several parts are getting assembled someplace else into the full drivetrain. The drivetrain and the other parts then get assembled into the vehicle, right? So several steps are moved. A long supply chain, global. Usually, you know, those, when you look at their supply chains, think of they're shipping all around the world before they get finally made. And then, but you know, the important point is that going from raw materials to the end, complete, and so you can make raw materials for the factory, and then also producing, you know, more of it there. That actually would be more completing what we're talking about in terms of a fully replicable factory, where you go completely from raw materials. I'll discuss that more. So Teslabot is the most important product, and I believe the Teslabot will be automating. People speculate about automating labor. If it's automating certain factory work and certain parts of the supply chain for these, for the various vehicles and the Starship, that would be in the mining aspect of it. That subset of work would be a vast enabling thing to speed up the goal of what I'm talking about, we'll be talking about. And Elon has said many, many, many times that the goal is for his city on Mars to be self-sufficient. By definition, if you make Mars self-sufficient, you move supply chains over there so that you can make other factories. That's just even a smaller part of self-sufficient Mars, is that it has to be able to make other factories of itself, of anything. And I'm just talking about being self-sufficient to make Tesla vehicles, SpaceX vehicles, and Teslabots. And this, the impact of this is something in terms of like the pinnacle of futurism is technological singularity. Or basically you have accelerating change, self-improvement technology, and explosion of capability, a phase transition where before it's slower and after is much faster and getting faster, and then infinite progress. All of that is contained within fully and rapidly replicable factories that self-replicate. And we want to have these factories that build factories transportable to Mars. And the amount of components we're talking about for that is not that much. You know, Elon's talked about sending 1,000 Starships, which would be 100,000 tons every 2 years to Mars. I believe like 10% of that would be sufficient to transport the factories to make the factories with their supply chain. And then if I'm wrong by factor 10, you know, he's talking about 1,000, and he's talking about like 10 years, you know, sending 5 waves of those 1,000 Starships to Mars. And then they're not going to be destroyed. They can even fly back from Mars to Earth because they can make methane fuel there. And NASA and Mars Society studies have shown that we know how to make steel, multiple ways to make steel on Mars. The materials are there for make steel. We can make aluminum, we can make glass, all kinds of glass, fiberglass. We can make cement, we can make fuel. And if you can make fuel, methane fuel, you can make all plastics and more on Mars. Water, fuel, air, everything can be made on Mars. They've something that the NASA Mars scientists has said, the studies, you know, using the materials of Mars to make things. We're going to make most everything on Mars we have to work to scale it up. And scaling up production is what Tesla and SpaceX do. Make gigafactories to scale up production and do it faster. A SpaceX engineer said, NASA should plan for Starship's significant capability. He when talking to a NASA ISRU, which is In Situ Resource Utilization, basically someone who's figured out how to use the resources of the moon or Mars to make other things, he told that person, Starship can land 100 tons on the lunar surface, 100 tons on the Mars surface. This Atari Matthews, the SpaceX Starship Human Landing System Program Manager, says, it's really a tangible weight. 100 tons is 4 fire trucks, it's 100 moon rovers, it's 11 elephants. We need to think bigger and better and really inspirationally what we can do with that. And this is what I'm talking about here, is how to get really big and huge with the vision of what can be done. And this is, he's just talking about one Starship. And, there'll be mass producing Starships and making hundreds of them a year, going up to thousands per year. So if you're an engineer thinking about how to use resources from Mars, what if you have no mass constraint? Because many of the studies, I've looked at all of them, about how do you, and then starting from the 1980s, how do you make stuff from Mars? They all think, oh, we have to be able to land 100 tons or 10 tons or small amount of material. It'd be like, how do I fit everything into a bread box? How do I fit everything into my car? Versus what if I could have a D-Day invasion and put everything there? If I don't have to make it smaller and lighter and just move everything, it can be done. You can move everything, because multiple countries have the full supply chain, right? And then certain islands have full supply chains. Japan's an island, other places are island countries that have a full supply chain. Cuba had to make itself independent. So 1981 study from Robert Freitas, who I've met fairly frequently and spoken to, he worked out how to make self-replicating factories. He's done very detailed work discussing what mining robots ever needed, and others have followed up on studies. There was NASA NIAC, NASA Innovative Advanced Concepts, work on an architecture for self-replicating lunar factories. A lot of that work where it's like, oh, we have to do some research is about how to make it small and lighter. If you go big and transport 100,000 times more material, it's a far simpler problem. And once you do it, you become fully exponential. One factory becomes 2, becomes 4, becomes 8, becomes 16, becomes 30. It keeps doubling. After 10 doublings, you're 1,000. After 20 doublings, you're 1,000,000. And something that SpaceX has been doing and Tesla has been doing is simplifying civilization in terms of like doing everything that we need in a simplified form. So, okay, if everything's solar and batteries, yes, there's 10, 20 other kinds of power systems that can work. But if you can do just solar and batteries and scale it, even on Mars with less solar light, you can then have infinite amounts of energy. You have the materials, I just keep making more and more. It's an energy positive, and then you just can scale up your energy. So you simplify it. You can do more, and eventually you may want to, but you can start with just one thing and then repeat it. The self-driving car, self-driving also means self-driving construction machines. So that Tesla's trying to make self-driving cars. There are 100,000 people who are beta testing it. And then you can then create self-driving construction machines. So if you have, they can make more automated factories, reducing the number of robots they need with gigapresses. Everything is reducing the complexity, reducing the systems, making things simpler, faster, and more productive. Teslabots and machines, Teslabot is something they say is the most important product. They will, do perhaps all human labor, but if you just replace mining, factory work, building roads and buildings, then you can have virtually unlimited production once you have those things. And like I said, 1,000 Starships can bring 100,000 tons to Mars every 2 years. That's 100 trains with 100 cars in each train versus 10% of one container is how much more materials we'll be taking. And the speed of gigafactory replication. So Tesla has already replicated. They have 4 major gigafactories, right? Just opened up Austin, Berlin. It took about 2 years to make Austin, Berlin. It took about 1 year to make one of the China factories because of less regulation. There'll be no regulatory delay on Mars. Apologies. No regulatory delay on Mars. And but they need to move the entire supply chain and also build that up. Assembling other robots are similar mass as a car. So then making the factories and make the factories is not some overly complicated task. Everyone knows what it is. Just go to the previous company supply chain, CATL, or someone else, and then incorporate what they're doing and move it to Mars. So we use about 1 billion tons of steel per year now. So that's enough for 100,000 tons. If that's all the machines you need for a gigafactory to make the mine and everything, assuming that's the number, I have a ballpark estimate, that's about it. Then you can make 10,000 gigafactories from billion tons of material. And then from those gigafactories, you can make 1 million Starships, because each factory that's a factory that SpaceX is trying to make now for Starships rockets is going to produce 100 of those. Then have a factory produce 1,000 Raptor engines and produce 100 Starships per year, 1 million Starships, even if you don't increase the productivity of that gigafactory. And then if you have making a factory making Teslabots, the same scale as the China factory, a Teslabot is 40 times less mass than a Model Y. So if you can make 2.5 million Model Ys per year out of a gigafactory, you can make 100 million Teslabots. If you have 10,000 factories, that you can make 100 billion Teslabots. So this is the kind of scale that you can get to by replicating up, and then you're not going beyond the billion tons a year materials that we have. So if you keep replicating up to the level of an Earth-like civilization on Mars, then this is the level of production you would have if you just started using the materials. And Mars is a huge planet, yes, smaller than Earth, but 1 billion tons of material per year, well within what can be done. So then you basically can industrialize the solar system from that point, where you take Earth, you replicate to Mars, and Mars was done with replication. And then you can replicate off into the asteroids and Venus and other places to continue to expand throughout the solar system. Now, let's look at the scale system where that doubling, there is the resources to scale up, many millions of times. So 26 doublings is about 64 million times beyond where we are now. We've been doubling our economy every 25 years for the last 100 years, the human civilization. And if you kept at that pace, it would take 650 years to fill up the solar system. But if you double every 5 years, which is what China did, China being 20% of humanity, they did that for 10 years, where they did like 2 doublings every 5 years. If you kept that pace up, that'd be 140 years to get to filling the solar system. If you double every 2 years, which is the pace that Tesla and SpaceX have been on for the last 10 or 12 years, then you could get to filling up the solar system in 52 years. So going from something that's in the distant future, 2700, and bringing that forward to before 2100. If you get started at 2048, 52 years, you finish by 2100. So you get to 1 million complete factories, 100 million Starships per year, 10 million Teslabots per year, thousands of terawatts of solar per year to make the planetary scale construction and to fill up the solar system. And with 26 W, you're still only at 1% of the solar system. You'd be filling up Earth orbit, the Lagrange points where the gravity balances out between the Earth and Moon. That's cislunar space. And go to Mars, the Mars moons, the asteroid belt. And there's time delays to get out to the Kuiper belt. So we will expand that out in this plan, clearly. But, I'm not assuming that we have breakthroughs in the speed of transportation. We likely will. I'm just not including that in this particular simplified scenario. And this is a diagram of the asteroid belt. Just beyond Mars is where it is. And here's Earth, there's the sun. And then over here, there's the asteroids that kind of are in Jupiter's orbit, 2 of them before and after, which are the Trojans, the Greeks. And that has about, the entire asteroid belt has about 1% of, or 3% of the moon's mass. But there's 2 other belts, the Kuiper belt out around by Neptune and Pluto and beyond, slightly beyond. And those have, about 1% of the Earth's mass there, about the mass of the moon, 30 times more than the asteroid belt. and then the Oort comet cloud, which is farther beyond that. So we go from asteroid belt 3% of the moon's mass, Kuiper belt 30 times the asteroid belt, and then Oort comet cloud 30 to 300,000 times the asteroid belt. So plenty of stuff to develop, to fill up the solar system. And when you have better technology, you can fully utilize this to occupy and make anything comfortable, massive space stations. But the first step in that big plan for the solar system would be fill up Mars with gigafactories, Teslabots, machines, and human workers. 1,000 starships, Elon's plan to launch, but instead of launching just a human colonization effort, is to launch gigafactory and supply chain that can make solar batteries, bots, and processing, and basically industrialize Mars in an exponential way. If you can do that in 1 year, which is what we did for the Shanghai factory in China, then you can get 1 million doublings in 20 years. And it'd be a Tesla SpaceX technological singularity, accelerating change by 1 million times by 2100. If you say, okay, well, certain inefficiency, the reality, blah, blah, you can still get thousands of times of a boost in production versus 10 times what we'd be on track to based on our current rate of change. To be a production explosion and the start of an infinite progression scale to fill the galaxy. But the major starting point is get a gigafactory with a supply chain, transport and build on Mars, and have that gigafactory rebuild itself, mine materials, and keep expanding production to make more and more starships. And why would we have them? Like I said, it's because there's so many asteroid materials, things to develop, things to do in space if we want to fill it up and really get going on a true space age. And what would be people doing? Well, we'd be working with all the robots. Loads of stuff to do. That's why Elon says, we don't have enough people, because if we want to, achieve a grand destiny in space, we need to do this thing. If we have to have the power of the future development, we want to develop solar system and then go beyond. And plenty of things that people can do instead of just sitting on Earth at a relatively static level. So solar system Mars, which is its goal, that means we can make new factories there. Mars will be able to make new factories. Mars will be able to produce other things and colonize another planet. Because if Earth can do that, then Mars, being self-sufficient, as capable as Earth, has to be able to do that. So the acid test for Mars colonization is an entirely self-sufficient place, not dependent upon Earth, which means the fully replicable, fully replicated factory capability. That includes self-sufficient includes that, and then just a matter of speeding it up. And Tesla, and SpaceX, and Elon are all about speeding up. So then, fully and rapidly replicable is just the short form way of saying, move it all there, be able to do it all there, and speed it up. A fully and rapidly reusable rocket, are 10,000 times more capable than non-reusable rockets. So, because if you're launching every hour, which you need the Super Heavy Starship and the Mechazilla catch and launch system, and for people who haven't paid attention to the SpaceX drone videos, they're making something called Mechazilla, which is a launch tower that can have massive arms that can catch the components of the Super Heavy Starship and then restack them, fuel them up, and launch them within an hour. So then you're launching every hour instead of like 4 times a year, something like that. Launching every hour is 8,760 times a year versus 2 to 4 launches for the European rockets and stuff like that, or once every 10 years if they're lucky for the Space Launch System from Lockheed and Boeing. So I'm not overstating things by saying fully and rapidly usable rockets are 10,000 times more capable than non-reusable rockets. And the fully and rapidly replicable factories are of the same scale, 10,000 times more capable than non-replicable factories. And they will enable exponential growth and 100 times more expansion of humanity over a century versus about 10 times without it. So that's what I think is on the cards for happening based on all the hints that Elon has been saying. And it should be the goal of Mars colonization, is fully and rapidly replicable factories, which is another way of saying, and we conquer the solar system fully industrialize it by 2100. Fully rapid replicable factories means we colonize the solar system by 2100, meaning we have not just Mars colonized, but millions of asteroids, millions of orbital space stations, the moon, pretty much everywhere we can. And it is, as a futurist, I can tell you exactly, the work NASA's done to research how to do these things in more detail, and like the space station capability, et cetera. But that work is there. The key step is making fully and rapidly replicable factories. So thank you for listening. If you like it, please like and subscribe to YouTube. I have other videos that describe other aspects of SpaceX and Teslabots and how these capabilities were developed. You can support me on Patreon and follow me on Twitter, all for Next Big Future and nextbigfuture.com. Thanks for your time, and talk to you next time.